going to review a couple of half-life problems that we've been practicing. In this half-life problem, it says the half-life of iodine 125. Remember, 125 is the mass number of this particular isotope of iodine that's unstable. It says its half-life is 60 days. It's always helpful to keep track of all of your information that you get in a time and amount chart. So remember, the most important thing is at the top of the time column, you always put 0. Every race starts at 0, so we need to start at 0 also. And the half-life, I'm going to make that a different color because it's so important, goes right underneath the time column. So the half-life, it says, is 60 days. All right, let's keep going. It says how much iodine 125 would be left after 360 days if you started with 2,500 grams. All right, so that amount that we're starting with is our starting amount, and we always put that in the type of the amount column. So we need to expand the time column until we arrive at 360 days. So you need to get your calculator handy if you're not going to do a lot of the math in your head. I'm going to do it just as a good example. All right, so what we're going to do is we're going to think about these half-lives. As each half-life passes, our amount is going to get cut in half. All right, so after the first half-life passes 60 days, the amount, 2,500, is going to get cut in half. So after 2,500 gets cut in half grams, I'm going to be left with 1,250 grams. All right, we need to keep going quite a bit until we get to 360 days. So another 60 days passes, so we're going to add another 60 days. We're up to 120 days. All right, what are we left with after we have another 60 days? So another half-life, we need to cut our amount in half. So we're up to 625 grams, or down to 625 grams. So it keeps getting cut in half. Let's have another half-life pass. So another half-life passes, that's another 60 days. We're up to 180 days. And this amount is going to get cut in half yet again. So when we cut that amount in half yet again, you can type it into your calculator or do it in your head. 625 divided by 2, we'll have 312.5 grams. All right, now we need yet another 60 days because we are not yet up to 360 days. This is going to take a while. I might run out of room. All right, so what we're going to do is we're going to have 180 days. We're going to add yet another 60 days to that, and we have arrived at 420 days. All right, so 420 days, what's going to happen to our amount? Our 312.5 is going to get cut in half, and we'll probably need to do that in our calculator. So 312.5 divided by 2, we're down to 156.25 grams. All right, still not there. We got to keep going. So another 60 days, and we're going to be at 300 days. Okay, after another 60 days, another half-life has passed. We're going to divide our amount in half yet again. So 156.25 cut in half, or divided in half by 2, is going to be 78.125 grams. All right, we have one more level, because remember, they wanted us to go all the way to 360 days. So add another half-life, and we'll be down to finally 360 days. We're going to cut that amount in half yet again, and we're to 39 point, and this is a lot of decimal places. We'll not worry about rounding for right now. So how much was left after 360 days? We have 39.0625. Now I'm going to expand the question a little bit and ask you how many half-lives have passed. So how many half-lives passed? We had 1, 2, 3, 4, 5, 6 half-lives passed where this substance was getting cut in half. All right, let's take a look at another example of a half-life problem. All right, for this one, it says the half-life of radium-226, remember that's the mass number of the version of radium that is radioactive or decaying, is 1,602 years. All right, so we're definitely going to need our calculator to expand this period of time because it's not an even number. So let's keep track of our information in a time amount column as always. And remember, at the top of the time column, always put a 0. If you don't put the 0, you're going to get into trouble. It's not going to work out very well. All right, the half-life, they said, was 1,602 years. So I'm going to put the half-life in a different color so that way we can kind of keep track of it. All right, as we keep going, let's read and see what other information it says. How much of a 60-gram sample would remain after 600 9,612 years. All right, so at the top of the amount column, we need to put the amount that we start with. The amount is 60 grams. All right, we've got to expand this time column until we get down all the way to this period of time. It's going to take us a while. All right, so what we're going to do is we're going to first start out with our amount column. So we know that it's going to get cut in half. So let's go ahead and cut our amount in half. So half of 60 grams, 60 divided by 2 is going to be 30 grams. So that's after one half-life has passed. All right, so now what we need to do is we need to look at another half-life passing. So another half-life, so that's going to be another 1,602 years. So that's going to be, we have to add that, we're going to be up to 3,204 years. All right, so our amount is going to be cut in half, so half of 30 is going to be 15. All right, so we're up to 15 grams. Now we need to keep going, yet another half-life, so we need to add another 1,602 years that have passed until the amount is cut in half again. So this time, when we add that, we're going to get to 4,806 years. Okay, how much are we going to have left? So we're going to need to take our 15 grams and divide that by 2. You can do it in your head or your calculator. You're going to get 7.5 grams. We're still not up to 9,612 years. So we're going to have another half-life pass by, or another 1,602 years. So after another half-life passes by, we're going to be up to 6,408 years. All right, how much of my sample am I going to have left? So we're going to divide the 7.5 in half, and we're going to be up to 3.75 grams. All right, still not there yet. We need yet another half-life to pass by. So as another half-life passes by, I'm going to be up to, let's see, 8,010 years. Is that right? I think that's right. So how much is going to be left of our 3.75 gram sample? So we're going to need to cut that in half. So 3.75 divided by 2 is 1.875 grams. All right, we need yet another half-life because we're not at the 9,612 yet. So let's go ahead and add 1,602 years, so another half-life interval. So now, finally, we're at 9,612 years. So how much of our 1.875 gram sample is going to be left? We need to divide that in half, and we're down to a measly 0.9375 grams. All right, so not that much left. So to answer the question, how much would remain after 9,612 years? This very small amount. And again, I'm going to expand on the question to see how many half-lives have passed. We've had 1, 2, 3, 4, 5, 6 half-lives pass during that time.